Okay, everybody, I'm ready for part B. The good thing is my instincts are right, so we're just going to roll with that. Okay, so now what we're going to do is we're going to add a ball to this system. Okay, so we're going to place a ball in the palm of this guy's hand right here. Okay, now it probably makes sense that like it's a circular object, it's a uniform object, so the center of mass is going to be right there at the ball. So we should probably state the center of mass of the ball, and we should probably put it right here. So we are now going to have a mass, and I'm just going to write it. It's the mass of the ball. Okay, so it's like kind of like a fourth item in our list of items that we have, like the upper arm, the hand, the lower arm, and then now the ball. So the mass of the ball is 14 kilograms. There it is. And the center of that ball, so I'm going to write I guess it's technically X4 and Y4 because we've already dealt with a whole bunch of other stuff. So horizontally, the ball's in the same position that the hand's in, as long as it's in the middle of the hand. So horizontally, the ball is going to be at 0.4. Okay, because we're holding the ball at the center of mass of our hand. So it's over 0.4 meters. However, the center of the mass of the ball is not at 0 because the center of the mass of the ball is just above the hand. So the fact that they told us what the diameter of the ball is, we need to figure out what the radius of the ball is, because if this line right here is the entire diameter, then the position of the center of mass is right there at half of it. So I'm going to do 7.4 because they told us that's what the diameter was. 7.4 divided by 2 is 3.7. So the center of the mass of the ball exists at 0.4, comma, oh, and this is in centimeters. So look how I did 7.4 divided by 2. I'm also going to have to divide by 100 because we need to change it to meters, not centimeters. So 0.037 is also important to write down for the center of the ball. Now, we have two options here. We can do exactly what we did in part A and do mass 1, x1, plus mass 2, x2, plus mass 3, x3, plus mass ball, and then the x value of the ball. But there's no reason to do that because we already found the center of mass of these three items, and I verified. I did this both ways to make sure. I can just take my answer of those three items. So here's the fourth item, right? So the center of mass for the other three items, we already found. And we found that center of mass to exist at 0.9451.09494. So we can just use this and treat the other three items as one item altogether. So that way we just have two items to do together. So you can do this two ways. You can treat it like four separate items and do M1x2, M1x1, M2x2, M3x3, M4x4, or you can just do it as treat like this is one big fat item, and then over here is another item. So I'm going to just treat it like the other three are one item together, since I kind of already did that. So the total mass of the other three items, is whatever the items are added together. So 2.5 plus 1.6 plus 0.64. So 474. Okay. Now, if you want to do it as four separate ones, go ahead. I did it as well, and I got the same answer, so it really doesn't matter. But I'm going to just treat it like two items. So these three items are becoming one altogether item plus this new thing that I'm adding to the system. So to find my new center of mass for my X, I will do this mass, 0.14 of the ball, times the X position of the ball, plus this mass of the other three items altogether, times the X center of all those other three items together, divided by this mass of 0.14 plus this mass of 4.74. And for my X, I'm going to get 0.1033. 0.1033. 0.1033. And this is measured in meters. So hopefully, hold on, I'll make an overall conclusion in a little bit just so I can kind of hopefully wrap it up for you, tie this whole thing together. Okay, so the y, we're going to do this mass, 0.14, times this y value, 0.037, plus this mass, 4.74, times this y value, 0.09494, divide by the two masses separately added up, put it in our calculator. Yeah, that's what I want. So that's 0.14. Oh, look, there's a vine to a grape there. 0.14 times 0.037 plus 4.74 times 0.09494. Now, did I put parentheses at the beginning of this? I don't think I did. Divided by 0.14 plus. And I'd really like you guys to kind of be doing this to make sure you can verify that you get the same answers I am. So 0.933. Oh, we're going to move it over just a little bit for you. I thought I could make it equals 0.0933. And this is also measured in meters. So I'm just going to write the new center of mass is equal to, and these are meters, 0.1033, comma, 0.0933. There you go. So that's the new center of mass with the ball. Now, if you compare that to the old center of mass, I want you to notice that the x's are very close to each other. The reason that is that the ball is going to pull the whole, what do you guys think? Will the ball pull the whole system to the left or to the right? Since it's adding mass to the right of the system, it is going to pull the center of mass to the right of the system. So that is why our new center of mass is higher, to the right. Now think about the ball again. Is the ball going to pull the whole system down or up? Well, that's a very difficult question because we are adding, like if you consider the overall height, the ball is a little bit lower than the overall height. So it is pulling it down, but just like by the super minuscule amount. So hopefully that makes sense. I'll put together for you.